welcome to this session. I'm Teacher Mbanga. So I'm a Christian. I always pray before I do my lesson. So shall we pray? Dear Lord, help us and help the learners out there to understand everything that you're going to learn in this video. In Jesus' name we pray. Amen. Alright guys, so today I want to talk about the math syllabus, Zambian syllabus. Also, worldwide others can also use it, but basically syllabus D based. So we're trying to look at errors. Okay, so we'll try to look at exam questions. We'll try to look at exam questions. Let me just check from another marker. Working. The black marker. Okay, it is here. So this is an exam-based video. So before I look at any past papers, let's try to look at what are errors. In most cases, errors are just degrees of accuracy. They are not mistakes. In mathematics, we do not say errors are mistakes. No. But errors are degrees of accuracy. And when you want to find the errors of any measurements that you can be given, mostly we'll be applying errors is equals to n divided by 2. So the error is the unit difference, the n, sorry for that. The n is the unit difference, okay? So in most cases we'll be dealing with the unit differences. If you are measuring, let's say, some length which are respectively, you've got 10 centimeters, you've got 11 centimeters. So if you are trying to find out the error between these two measurements, we're going to say the unit difference is 1 centimeter. So our error will be 1 divided by 2, so it will be 0.5 in such a case. One day we'll be trying to look at some measurements which are going to have maybe, let's say, 20, maybe 20.1. So try to understand what is the unit difference between this measurement, let's say grams, to the next measurement. Since it has a point, we're going to say, okay, our n is 0.1 in such a case. Okay, then we're going to say the error for such a measurement will have n divided by 2. So we're going to have 0.1 divided by 2, which we are going to get 0.05 in such a case. Maybe we can have a measurement which is going to have maybe something like 9.45, let's say centimeter cubed to be the volume. So what would be the difference? What would be the unit difference to that, or what would be the error for this? We are going to say, okay, in this case, our n will go to decimal places. The unit difference is going to be n is equals to 0.01. So we are going to say n divided by 2, our 0.01 divided by that, we get 0.005. Just like that, okay? So that is just like a basically idea of how you can find the E or the error and so on and so forth. So take note of that. The other thing that you need to know under these errors are formulas. So formulas are very vital. As we look at any exam-based questions, we need to know the formulas. So the first formula is absolute error. There are types of errors. The absolute error, absolute means positive, okay? So we are going to say absolute error is the modulus simple. We are going to say true value minus measured value. Okay, the answer must come out positive. Even if there is a negative inside, it should come out 2. That's what it means by absolute. Truly positive without any interjections in such a manner. Okay, the other type of error that we should know, the formula is relative error, comparing. the relative error. It is the difference or the ratio of the absolute error to the true value. So we are going to say absolute error divided by the true value. Others will say actual value. Okay? Then we also have percentage error. So the percentage error, hope you are following. You people, I forgot to put my phone on flight mode so that people should not disturb me. So percentage error, there are two ways in which you can find percentage error. The first one, you can say, I wrote some things on the other board so that it can be easy for me. You can say the very formula, absolute error over true value times 100%. Or if you don't want, you can say relative error times 100%. That is also fine. The fourth formula you need to know is tolerance. The tolerance that can be allowed to some measurement, which is the difference between the upper limit minus the lower limit. This video can be used for GCE, it can be used for grade 12, it can be used for grade 10s, whichever that you can feel it is still okay. So upper limit means you getting the true value plus the error minus true value minus the error, this side. Okay? Then, when you start looking at the exam questions, there are times whereby they will ask us to find the maximum length. Sometimes it can be the maximum grams or whichever volume, but so just the maximum measure. Any measurement that they can require to be the maximum, we can say the maximum measurement is equals to the upper limit. And you know the way we find upper limit, we say true value plus error. True value plus error. The last one, ladies and gentlemen, it is a minimum measurement. Minimum measurement, which is equals to the lower limit. And the way you find the lower limit, remember, it is equals to the true value minus error. Okay? That is the end of everything we need to know for syllabus D, the Zambian syllabus D for that. Let's go to exam questions. Let's go to the exam questions. I'm wrapping this. So you need to recall, you need to write them down somewhere so that you recall them. Okay? So I'm using this Daploid. They are our friends, they help us with this, the booklet. So the first one, ladies and gentlemen, that we have is on page, let's start with the easiest one so that we can see, we can find it very easy for our friends to follow suit without any interjections. Okay. Looking for the easiest one such that people can really follow. So it is on page 39. For this booklets, just go to 2017 November, question 15. They said Misozi and Filamba estimated the length of a line to be 9 centimeters. So the information that they've given us is that the Misozi and Filamba estimated, so meaning estimated line was 9 centimeters for Misozi, then 10 centimeters was for Filamba, Then if the true line was, so true measurement, true value was 9.6 centimeters. Find Miso's absolute error. So question A is saying Miso's absolute error. By yourself this to be easy. So remember, Miso's absolute error, we are going to say absolute error is equals to true value minus measured value. Okay? So the true value is 9.6 minus measured value. The measured value for Miso's is 9 centimeters. Okay? So absolute error, if we do this, it will give us 0.6. So meaning our absolute error is just 0.6. We are done. Okay? Our absolute is 0.6. It is done. Done and dusted. So now, if we were told to find for fill numbers, imagine a question. If we are told for fill numbers, imagine if there was a question for fill number, we would have done the same thing. Absolute error is equals to true value minus measured value. Okay? This is for fill number. So we could have done the true value is 9.6 minus 10. Okay? So in this case, it could have given us, if we do 9.6 minus 10, it will simply give you 0.4. So this would have been 0.4 with a minus there. Then since we are saying absolute means positive, our answer is still positive, which is 0.4 without a negative. That's what absolute entails. Okay? So that is for that. But we were not asked to find the fill number. I just did that to show you how it can be done. Now, let's go to the question B. Question B, ladies and gentlemen, is saying fill numbers percentage error. Fill numbers percentage error. Fill numbers percentage error. Remember from the formulas we say percentage error, there are two ways. You can say absolute error over true value times 100%. Right? So fill numbers percentage error, the absolute error for fill number we don't have. You have to find, and I just did that from the illustration, which is 0.4 over the true value for fill number. Where is fill number? Fill number is here. This is estimated, but the true value is 9. 9.4 times 100%. You have to find easy ways of dealing with these numbers in paper 1 because there are no calculators allowed, ladies and gentlemen. So the easiest way you can do is if you multiply 0.4 times this, you cancel 1 and you also cancel that, then you multiply 4 times 10 to give you 40 up, down to give you 9.4. So we need to get rid of this decimal by multiplying with 10 because of 1 decimal, down 10. On top, we are going to get 400. Down, we are going to get 94. Okay? Then begin reducing. They are saying percentage error, so it will have a percentage. So if you continue reducing that, you are going to discover that you are going to have, in a fraction form, you will have 4, or number 4 up 12 over 47%. If it was in a decimal form, it's 4.2. 4.255 percent in that format. Okay, in that format. So that is how we can deal with that. So that question is done. That question is done. We can go to another question. So once you can try more exam questions on the absolute error, on errors, everything. Otherwise, we are done. We have nothing or nothing more and nothing less. Page 7.
Oh, you have an online class?
No, I'm just shooting a video.
Okay.
On errors.
On
errors.
Oh, it's just shooting.
Page 7. So page 7, we have 2016 October, which is question 13b. They say find the percentage error. Find the percentage error of mass of sugar weight 10.00 kg correct to 2 decimal places. That's the question. So remember, percentage error is equals to relative error times 100%. Okay? And you know that relative error is absolute error over true value times 100%. So what is the absolute error for this number? It is as good as you finding the error, which is n divided by 2. You can't apply true value minus measured value because we don't have two information, we don't have two numbers. So we are going to apply the error formula. This is a unit difference. Look at this, it has got 0, 0, the 2 decimal places there. So it is 0.01. Okay? So in this case, we are going to say our absolute error is 0.01 divided by 2. So our absolute error, we are going to have 0.0, it can't 0.05 like that, 2 zeros. Okay? So we are going to now say 0.005 divided by true value is this guy now. 10.00 times 100%. Okay? So in this manner, we are saying now 0.005 times 100%. It will give you 0.5 divided by 10.00. So the answer will be 0.005 0.05%. So that becomes the percentage error, corrected to 2 decimal places. If you are wondering how that is done, you can cancel 2 zeros this time, this and this and this goes 1 times 5, it will give you a 5 over 10. Then you continue 0.00, so you add that, you multiply, it will all lead you to the same thing. So, ladies and gentlemen, we can solve and just get tired.